shout today. And for your awareness, we do have
Thanks, Jay.
Saturday. Those who don't know what we're talking about.
Oh, listen up real quick. It's hard to hear.
Guys and girls starting basketball at Fannin County.
Everyone's got
Get after it.
You do
Make it a great day.
I would, but
To go to the Fanning?
Yeah,
that's a
Hey,
Yeah.
as we get started, hey, let me start with this. I want to just give you something motivational. I woke up this morning. I stayed up till about the third quarter, or end of the third when it was done. But I heard this. This is the coach of Clemson, Dabo Sweeney. He's awesome. I want you to check this out, listen, and then we'll get rolling, all right? So again, you might want your calculator out, notes, and your homework. We're going to get it rolling here as we listen to this. Here we go.
I hope that you get a little hope from us and a little inspiration that, hey, if we can do it, anybody can do it. And that's I mean that. Listen, if a guy like me, I said this 2 years ago, I mean, you can't write a Hollywood script like this. Only God can do this. And that's a fact. And people may think I'm crazy or quack or whatever, but only God can orchestrate this. You can't, no Hollywood producer can write it. But I'm just telling you, if I can do it, if these Clemson Tigers can do it, hey, anybody can do it if you have a belief in yourself and what you're doing, and you surround yourself with a bunch of great young people that are passionate about winning. And tonight, we conquered a mountain that ain't ever been conquered. The flag's on the top, and man, I can't wait to celebrate.
Man, I love that. I love some good stuff just in that 45-minute segment. Anything stick out to you? This isn't character development time. I just was motivated by it. Anything stick out to you that was eye-opening, maybe?
when you talk about how you know all the stories, you can write it like that.
Yeah. Yeah, only God could write that story. It's interesting. I could share with you time and time again things even God's done in my life where I'm just like, man, absolutely incredible. And so it's just something when you look at your life, man, trusting in God, huge thing. You check in on me? You did? You did not? Would you mind doing that? Thank you, sir. As we get started, prayer requests today before we get rolling, because we got to hit the ground running today. Anything that you say, Coach, I got something we could pray for. Let's start on a right note on Tuesday. Anything we could pray for today? Alabama's campus.
Yeah. That's, I know it's dead.
Yeah, there you go.
Nobody's
No, they'll be fine. Yeah.
17 others.
Anything else we could pray for?
Pray for Auburn's campus. Yeah. And Michigan.
And then that. Anything specific?
For, like, it's about a month out, the mission trips, like
Yeah.
the winter mission trips. Just kind of for certain things.
Absolutely. I'm going to pray for y'all seniors just because there's a lot going on in terms of decisions and excitement for this semester. It's good. Anything else? Perfect. Let's pray. We'll go. Father, I just ask in Jesus' name that you would come amongst this group. God, I want each of these students before they leave GAC to understand that, like we saw behind me, that they have a purpose in this life. That is bigger than anything that they could ask or dream of or imagine. Lord, that doesn't mean that times aren't tough, because I know that they are. But Lord, we can trust you even when times are tough, that you've got a bigger purpose, that you love us, that you care for us, and that when we look to you and we trust you, Lord, everything changes. And so, Lord, if there's anyone that has not experienced your love and has not accepted you, I ask that they would experience you even today in this moment. Lord, I also think of, as Jackson brought up, the mission trips. Lord, I ask that you protect individuals on that, and then also allow it to be a great opportunity for service in that way. Lord, be with unspoken requests that in this room. Be with those in Jesus' name, amen. All right, hey, let's go right straight into it. If you could take out, we're going to go to number 3 down below. I know I kind of skipped the warm-up today because I was a little fired up about what was behind me. But here's what we're going to say just as we get rolling. Block day is going to be when the homework is due, 2.1. both A and B by midnight. So that will be by Thursday at midnight is when this will be due. Today's lesson is going to be a lot of doing the problems. So like I said the other day, you're going to notice that a lot of the lesson that we're going to be teaching is going to be off of the homework that I've given to you. So make sure, again, as we keep going, take out a calculator, pen, pencil, and your homework, and let's get underway. Here's the first thing I want you to do, and if you have some struggle with this, let me know. I want you to graph this quadratic off of your homework, okay? Do you like the format of the homework better? I tried to do a little bit easier. Hopefully that's helpful for you this semester. I want you to identify the vertex of this using your calculator, and then also I want you to do the axis of symmetry, the x-intercepts, and so on and so forth, all right? Does that make sense? So I want you to start right now. Go ahead. I'm going to give you a couple minutes to get started on that, and then we'll begin, all right? So go ahead again on number 3. Did we do this yesterday? Like putting it in our calculator?
Would fx be y? Would that be like y?
Yes, this is the same as y. That's a function, but the output would still be my y there. Clear?
Alright, I'm putting it in my calculator.
This.
Yeah.
No. I see like that.
Oh, this is...
Yes,
Keep forgetting
I
your
know.
theory.
Yes, please.
Okay. What we'll do is, Claire, you can, because you have a calculator, it's not like you don't have one. You can just use mine, and that way, everything I do behind me, you'll be able to follow.
Okay, great.
When there's a
For some reason, we need to charge it.
Yes, that's like, wait, you
I wasn't sure if like there was like a way to find the word things like
Oh, yeah, so you can actually calculate it. Is this not calculated? So you can do this by going to second trace, and then go ahead to the maximum, which is number 4. And then that's where you go left bound, press enter, right bound, press enter, and then you guess. Does that make sense? Perfect. If you're having some problems too, what I'm going to do is I'm going to allow you to kind of go, and then I'll be walking you kind of through parts of this as we solve it, okay? So keep trying that. We'll be...
Hey, listen, I hope that you get a little hope from us, a little inspiration that, hey, we can do it, anybody can do it. And that's I mean that. Listen, if a guy like...
Did you see the Michigan coach yesterday?
I did, yeah.
That's crazy for Ohio State.
Oh, man.
That's insane.
It's insane.
Like, coach, so once you get this,
Chris,
Say that again?
once you get this, how do you put the little brackets on your thing to find like the vertex?
Second trace. You go to second trace. So when we plug it in, just as a heads up, if you're following through,
And then you hit 0.
yeah.
did you get 0?
What did I hit 0? Right?
Well, if you're finding the x-intercepts, right? But if you're finding the vertex, this is a maximum, right? So we go to maximum.
So
That's why you guys did long.
You got some, Jackson?
So for the thingy, the maximum, we put the like x comma y.
Correct. Yeah. For the maximum is, if they just ask for the maximum, x comma y is perfect.
So we go to that.
You all good on this?
Yeah.
Plug it in.
What's this unit? What is this? This unit's just here. Graphical.
31. Oh.
That sounds right.
That's 6.
Yeah.
Oh, that's just the decimal, right? So it would be really be like negative. I would say negative 0, comma, whatever the y is. And just go to zoom out. And when you do, you have to first you can press enter. You just press enter right there. When you press enter, that's where it comes out. You just see that was it. That was your only part there.
Yeah, but
Did you just sit there on the zoom out part? I got you. All right. So, is there anyone that's struggling on finding the different components? I think a lot of you are starting there. In case you are struggling, if you are, I'll kind of walk us through. Before I do that, though, is there anyone that's struggling on getting it in your window? Are y'all feel pretty good on that? Cool, so we'll zoom out. We'll make sure we zoom out there. It should look something like this, okay? Thank you very much. Appreciate you, dude. All right, should look something like this. Now, if you go to the vertex, right, is this a maximum or minimum? A maximum, good. And Michael, is there a minimum? Yeah, there is no minimum because it only hits the top and comes down. So what we want to do is to find what the maximum is. We go to second trace, okay? And when we do that, we'll go down to this maximum side, which is 4. And where do I go left bound? To the left, and then to the right, and then right straight in the middle, okay? And you should have gotten negative 5.0, comma 30.25, okay? I will tell you, highlight this number. This will be on the test, or one almost identical to this will be on the test, okay? All right, so we got the vertex. We've got that. That's good. We've graphed it. What is the axis of symmetry? I'll give 4 tickets if you could raise your hand and tell me what is the axis of symmetry. Jackson.
X equals negative 0.5.
Good, yeah, because it's always the x for us, right? Because that's what divides it in half. Whatever the x is of my vertex, maximum or minimum, that is the line that you can divide over top of itself, okay? All right, and Sophia, I know you weren't here yesterday. If you start say what? Tell me, okay?
Okay.
All right, so that would be the axis of symmetry, okay? Questions? Cool. Next part, last part, x-intercepts, right? X-intercepts is a big thing because now we're trying to see where it hits the x-axis. How many do we have here? We have 2, so we're going to have to do this twice. So how do I find that on the calculator?
0.
Yeah, zeros is the gangsta name, right? We talked about that?
Yep.
So 0. And so if I'm finding this left one, because I'll need to do it twice, what is the left bound of this left 0?
Below.
It's got to be below because it's like the left side. Good. Jackson, that's good. So I go here, press enter. When I go right, I've got to go above it. If you do not, it'll tell you error, and that means that there was no change in sign. So I've got to have one that's below, one that's above, and then the guess will be somewhere in between to give me negative 6, 0. Okay, and that's how I would put it, is negative 6, 0 for that first x-intercept. Okay? Remember to do it again, because that's a big part of it. So go into second trace again, go into 0. This time I'm going to go to the right-hand x-intercept. So I'll go to the left, press enter. To the right, press enter. Middle, press enter. And I should get 5, 0. It's not.
Oh, you got the. That's tough.
That's okay. Yeah,
You
if it's somewhere close, it's okay. Yeah, you'll still be good. Say again. Yeah.
Can you do below for the left one, all the way on the other side?
Over here? Yeah, so if I'm going to this x-intercept, when I go left, because of where the location is,
Yeah.
I've got to go above it.
I see.
For that.
But could you go up, down, all the way back down, and then below? Because it's still technically left.
I don't know. You have to try it. I don't know how that would work there. But good question. All right, any questions that y'all have? That was kind of what we hit on yesterday. Hopefully you got that down within your notes. I will give you 6 tickets right now. If someone that hasn't gotten something today, tell me how I can do it not graphically, but algebraically. How can I find the x-intercepts algebraically? Roy, you got something?
Quadratic formula.
Good, yeah, so we've got quadratic formula. Good. You know how else we could do it, Roy? Factoring, yeah. I always start with factoring first because I think it's easier. If I can't do that, then I go here, right? That's good stuff. So really, remember x-intercepts we talked about yesterday. This is equal to 0, right? So 0 equals negative x squared plus x minus 30. And can I factor this right side? Yeah, to what? Good, Madeline. I think that was you, right?
Yeah.
What'd you say again?
6 and 5.
Good. 6 and 5. And when I said both of these equal to 0, y'all remember this?
Yep.
Am I like going out there? I hope we're good. And when I said them both equal to 0, what does that equal? -6, and this one is +5.
Don't you have to account for the negative sign?
That's a good question. Technically, not necessarily, because let's say I did put the negative to both of these. That would mean that this would be -x minus 6 equals 0. So if I added 6, and then divided by -1, it would still be -6. Does that make sense? Because it would go to both parts. So it wouldn't change anything, although you could do that. So this would be -6 and 5, which is the same thing that we just looked at earlier. Okay? Off the calculator. How would I find, Claire, do you remember how we found the y-intercept? That's fair. I was just curious. Anybody remember how we found the y-intercept? Yeah, we put 0 in for x,
Like,
right?
okay.
So if I put 0 in for x, what's the y-intercept here?
Oh,
I heard it.
-30.
-30, good. Because if I put this in, 0 in here, plus 0 minus 30, that'd be -30. Okay?
But
Hold up.
no,
Did I mess that up?
yeah. It's
What would it really be?
positive.
Positive, yeah. Because of the negative that's on the outside. Good. Who corrected me?
Madeline got it right the first time.
Oh, okay.
Yeah, you got +30. Okay. Any other questions off this? Good stuff. Okay. Here's what I want you to do really quick. I created this new thing for at least this unit. I want to see if this helps you or not. I don't know if you want to get all of this down, but I'm going to do what's called the Golden Nugget page. This is everything you need to know for this section, okay? I would take a picture of this, maybe using your phone. I know I told you to put them back there. So if you want to get them real quick, take a picture and then put them back, that's fine. But this is all of the stuff that you're going to need to know for this unit, okay? So this is all like the fundamentals that are here, okay? A lot of this we've already covered, and some of it we haven't, which we're going to go over here in a second. But I wanted to give this to you before we go any further on this stuff, okay?
Coach Jay,
Yes, sir.
you put these on campus, don't you? These PowerPoints?
The podcasts are, yes, sir. So yeah, I don't put the actual PowerPoint, but the actual video I do. So yeah, if you just want a picture of it and then to come back to, does this help y'all per section just to have something to go back to? I'm just gonna kind of do this. This doesn't mean that this is everything, but this is definitely the main stuff. Okay. Let's do this really quick because I'm gonna have something where we're kind of work together here. We're going to look at this part in blue called our transformations, okay? Do y'all remember transformations from previous years? No? Okay, fair. Some of you said yes, some of you said no. We know that x squared is our picture for a problem, right? Okay? We know that if we had one at y equals x squared, where would the vertex be for y equals x squared? 0, 0, right? Good. And I think I've got a good color here. So this one would be a vertex of 0, 0. Would it go up or would it go downward? It would go up. Do you know why? Good. It's not negative. It's actually positive. So I always think like it's like a smiley face. I'm positive, having a good day, right? But if there's a negative, it's going down, having a bad day. Okay? I don't know if that's cheesy or not. Probably. So what about the reflection? What would the vertex be for this one?
0, 0.
Okay, it would still be 0, 0, but, Sophia, do you know whether it would go up or down for this one? Good, and would it have a minimum or a maximum? No, that's fair. So if it's going downward, right, the vertex, you weren't here yesterday, so that's okay. The vertex is up here, right, the very highest point. Therefore, this would have a maximum. Does that make sense? And therefore, if it was going upward, the vertex would be a minimum. Okay, cool. So we've got still 0, 0, except this is what we call reflected. Okay, so if the negative's in front of x, we say it's reflected. What about x squared plus 1 How would the vertex be changed if I added a 1 on the outside? Someone raise their hand and help me. What would that look like there? Noble, do you know?
Which one were we talking about?
X squared plus 1.
What would it look like?
Yeah, what would the vertex do?
Well, it would go up 1.
Yeah, it would go up 1, right? So what would the vertex be then?
It would be 1. No, it'd be 1, 0. No. Wait, yeah, no, 0, 1.
0, 1. Good. So this would go up 1 because it's on the outside. That's a big thing. So therefore, this is going to be 0, 1. I'll tell you this. This is a big part of what we're going to do today and in through the next couple of days. So hang tight in here. What about x minus 2 squared? What would the parabola do on that regard?
Go to the right.
Great job. Why did you say right and not left?
Just switches when it's inside and opposite.
Great job. The horizontal is inside and it switches sign. So it actually would go to the right 2, which would make the vertex what, Claire?
0,
Except the x comes first, right? So it would be
2, 0.
bingo. Good. 2, 0 would be my vertex. Very good. Questions on that? Rocking. The last thing is a little bit different. So we have all of these transformations. The 2x squared and the 1/2 x squared are probably the toughest, okay? And we'll hit on this and then keep going. Traditionally, if this is x squared, we'll just say that this is the picture. What happens when I put a 2 or a number greater than 1?
It gets skinnier.
It does. Good. Good, Chad. It actually gets skinnier. It actually what we call stretches, okay? So if you think of a rubber band, if I were to stretch it, what happens? It gets skinnier, right? So that is a stretch. The higher the number, the skinnier it is. If this is a number between 0 and 1, which is like a decimal or a fraction, what happens with that?
Wider.
It gets wider, right? So then it's going to kind of open up. It's like I'm pushing it down. Think of like, if I'm shrinking it, think of like a Nerf ball. I don't know if I've got one around here. I thought I did. Over there, if I pushed it down, it's getting wider, right? So I think of a shrink as getting wider in that way, okay? So a stretch versus a shrink. If you're good, say uh-huh. If you're good, say uh-huh. Any questions on that?
I feel like it should be called gyroid.
Why do you say that? I've heard that before.
Because if you shrink it, I feel like you're making it skinnier.
I 100% agree. I would just look at mine. Let me go behind Tumnus here. If I look at a shrink and I was pushing it down, what's happening? Yeah, it's widened. Whereas I think the rubber band's key for me.
Yeah.
The stretch, it's getting skinnier, right? I don't know why that in my head, but I agree with you. I would just say if you ever get confused, think of that illustration and that'll help, okay? All right, do this for me. We're going to go backwards here towards, had this right here. Okay, here's what I want you to do. Can y'all see that? Can y'all see that? In your group, partner up with someone. I've got 2 tickets per person for the first group that can match these up through 1 through 8. Does that make sense? So all you're doing is this, right? So like number 1, Claire helped us with this. What type of transformation's happening with number 1? Right 2. So this graph is moving right 2. Is it going to go up or down? Up because it's positive, right? So you're going to match up the graph with the equation, all right? Could you do that real quick?
Is this on here or no?
Ready? It's not on here. That's probably the only thing that's not on there. Okay, we will in a second though. Ready? Go. Do it. Match it up. Match it up real quick.
I'm expecting great things out of you, right? You do the left 4, I'll do the right 4. I do the left 4, I'll do the right 4. No, we didn't.
I have a good question.
Yes, sir.
Cranking it out.
Like when you ask about x-intercepts, how would you do that? Because like, I know you know where the vertex is, but like, would you go down, down,
Oh no.
What I would do is just do a t-shirt. I'm gonna do that here in a second.
Okay, so we'll blend that.
I'm actually gonna do this one. Do this one here. In just a bit. You're right. You're right.
Jay,
Yes,
can
sir.
I use my phone for the picture we just took?
Why did you
You long as you're not on it, you're good.
Wait a second.
So, can I ask you a question? Is that transformation? That's just the basic.
Correct. Yeah, because it doesn't have anything
okay,
next to it.
just making sure.
That's a good question.
May I get water?
You may.
Cafe.
Yeah. So F is hold up. It's not all. So F is fine. No, yeah. We're done.
Y'all are done? Cool, keep going. I'm going to check it real quick.
Lying is a sin.
Hey, I wish they were right.
Hey, yes, it's 22.
What?
No, 19.
We're also
No,
done.
20,
And they really cheated on us, so.
2050.
Ooh.
Just like Dabo cheated last night. You watched that?
You watched that? You doing the work.
Nicely done,
They were
guys.
outlaws.
Good. I don't know what y'all- we go. Let's-
There's no way they just beat them like that.
Yeah, actually, they did.
Hey, when you're done, go ahead to numbers 1 through 4 off of your sheet, okay? Off of your sheet there. I'm gonna check real quick.
I swear by dogs.
Y'all get them?
When I first saw them for Jeep,
Dude, if you got yeah, there's one and then I think dude, this touchdown throw, the one like one or the other.
4?
I
Oh, that's a tough one because it's rearranged, right?
Yeah.
So what I would say on that one is let's rearrange it back. Where did my? Here it is.
Like literally.
So change it around to where you have it to where you can read it. So instead, go f of x equals negative x squared plus 3. You see that? So what does this mean?
It goes up 3.
Yeah, then that means that it's reflected downward once I go up 3.
Yeah, I suck at that.
Okay?
You check it out. Yeah, it's-
Absolutely.
You got 7.
If you would,
Is there an
Yeah.
E?
6.
Yeah.
B
That
was
was
3.
pretty.
C was 2.
That was perfect. Like, he did
D was
his.
8.
He got it right.
E was 7. F
And
was 5.
they're
G
like,
was 1. H was 3.
recently.
Good. Do y'all feel pretty good on this then? Is there any ones that you struggled with? Y'all pretty good on them?
What is that?
It's for the perfect polynomials. Do this before you leave if you want to take a look.
That looked like, what's the yellow?
Yeah, absolutely. Say again? Yeah, they did. That was what we did for the ticket.
Oh.
Okay, hey, do this for me. Look up here. Was this? How did this feel? You feel okay?
What's with the number 4?
Number 4? Yeah, this one, that one's a little challenging. Here's what I would say, okay? When I identify with number 4, I was telling Michael, go ahead and rearrange 3 minus x squared to what you know and what you see, okay? Just make sure you take the sign with it. So go ahead and rearrange it to negative x squared plus 3, okay? That makes it much, much easier.
So it's not a stretch, it's a Y.
Correct, yeah, because the only time it would be a stretch is if you had 3x squared next to it. Like the 3's got to be attached, right? That would be a stretch there. That would make it skinnier.
So same
Right.
thing with 5, put the 4 on the right.
Correct. Yeah, so this would be up 4 because it's on the outside. Claire, what is x minus 2?
It's gonna move to the right.
Great job. And then the negative is down, reflected downward. Great job. Good work. Questions on that? All right, yes, go ahead, Michael. I'm sorry.
When we're drawing it, is the slope 1/1?
That's a great question. Can we do another one? The ones on the front are pretty easy, I think. Let me identify with another one off your homework. 25 minus x squared. Can we do that one? Let's do this. Let's just talk through. Here's the expectation, okay? I'm going to give you the expectation for graphing. Pay attention because I don't want you to miss this. This is not something that you should miss. It's not too challenging, but if you don't do it appropriately, you could get some points counted off there, which I don't want you to do there. We want to rearrange this first, right? To what? Yep, so f of x equals negative x squared plus 25, okay? The vertex, let's identify with what the vertex is. The vertex is going to be what?
25.
Yep, so 0, 25, good. And identify, is that going to be a minimum? Well, let's talk about this first. 0, 25, I'm going to go by 5. So 5, 10, 15, 20, 25. As long as I label that, I'm okay. So this is the top. Is this going to go upward or downward? Downward. So this is going to be, the vertex is going to be what? A minimum or a maximum? Maximum. Good, yeah. So it would be a maximum there. Good stuff. Okay? Is there a minimum?
No.
No, there's not. Okay? So it's either one or the other. The next part we're going to do is we're going to go ahead and attack the x-intercepts. How can I find the x-intercepts of this? We can calculate it.
You need a T-chart, coach.
Okay, so x-intercepts on our golden nugget, we plug 0 in for what? 0 in for y. It's the opposite, okay? So 0 goes in for y. So this is 0 equals negative x squared plus 25, okay? How do I solve this? You can put x on the other side. This one's a little easier, you don't have to factor. So we could add x squared to the other side to get x squared is equal to 25. And what do I do now? X equals 5. There's one thing that's incorrect. If you can raise your hand and help me, Jackson.
Plus or minus 5.
Plus or minus 5. Good job. Good. So what we can say here, I'm going to make this by 5s here. This I'm going to make by 1s, which is appropriate. I know it's going to skew what it would look like, but that's okay. So we have 1, 2, 3, 4, 5. 5 to the left and 5 to the right for our x-intercepts. Okay? All right, so we have 5, 0, and negative 5, 0. Good stuff. Okay, so here's our x-intercepts. 5, 0, and negative 5, 0. That's here. Let me pause for a second. Questions on what I'm doing with this? X-intercepts, vertex, all that stuff? Okay?
Will the axis of symmetry always be the x of the vertex?
Yes. Mm-hmm. So if I said, what is the axis of symmetry, which I don't think it asked for, you would say in this case it's what? X equals 0. Because it's always the, like this vertex is 0, 25. It's always the x in my vertex there. Right?
Are we going to do the things where they're
like side to side? Yeah. The end of the semester we will. And in that case it'd be y equals.
Yeah.
But yeah, we're not there yet. You're not old enough yet. But maybe someday, you know? Maybe someday. All right, any questions on this? Now here's what's cool about this, okay? Let me pause for a second and help you with kind of my expectation. As you do this, if you've got the vertex and you've got 2 points or 1 point to the left and to the right, do we have enough information to graph this? Yes, we do. So we can actually go ahead and attack it and go like that, okay? However, you need to hear me out on this because I've heard this or I've seen this done before. Let's pretend that you had a vertex here and it was supposed to go upward, okay? I've seen people, and this has happened on a test. This is what happens. People have done this. They'll just go like this, okay? All right? That is not, you won't get full credit on that. So what is the expectation? If you do not have any points to the left and to the right to make it accurate, does anyone have an idea of what you could do to make it to where it was more accurate to the left and right of my vertex?
You just go up 1 over 1.
Not necessarily, because when you think of it, right, a quadratic, like it's not going to be even. Now, an absolute value will be like a b, right? But sometimes it's not constant, like it's not up 1 over 1, up 1 over 1. So what do? We create a t-chart, okay? So in that situation, you would plug in one value to the left, and you know that it would mirror over to the right-hand side. Y'all know what I'm talking about when I say this? Okay? So just be careful of that. Don't assume that, oh, I can just write this. You'll get partial because you'll find the vertex. But to get the full credit, make sure that you show work there. Okay?
But wouldn't you count yourself wrong on that one?
This one?
Yeah,
Why is that?
because it's way out of scale.
As long as I label, I'm okay. So if I say, probably to make it correct, I would probably, and it's hard to put it because my pen here, but 5, 10, 15, 20, 25, as long as I label, I'm okay. It's appropriate to have a different Y than X, as long as I label, you know? Now, if I don't label, that's when we'll get the full credit there. I know this is out of scale because it really should be like way up here, but that's okay for this problem, as long as I show it.
Well, even like I was thinking, because on mine I did like 1 square is 5, like, and so it was like the x intercept is technically like 1, 0.
Oh, you could do that. So if you wanted to, Jackson said, well, if each of these tick marks are 5, then I'm going to make each of these 5 as well. You could do that. But you could also say these are by 5s and these are by 1s.
Okay.
As long as you label, your graph may look different than each other's, and that's okay. My big thing is the work and then how you label it, okay? And then having enough work on that. Questions? So the first 4 on your homework, right? Y'all see those there? I'm guessing y'all should be okay with these, right? These are pretty easy. These are pretty simple. I don't think that these are too tough. If you look on the second page, okay, just as a kind of heads up here, you see this 1/3 x squared minus 3, okay? All right, just make sure on this one that 1/3, it's going to make it a little bit wider. So take that into account. Once you've solved for it, all the stuff we've solved for, we should be okay in attacking it. And go
But like
for it.
1/3 over x, you just go up 1 over 3. Make it wider.
Not necessarily.
How do you know how much?
No, you put it in your calculator.
Do you need a
Well,
calculator
you
for that?
do 1. The x is either you do 1, 2, 3.
Okay.
I would do the same thing. I would go, what's my vertex? Let's find it. Let's find my x-intercepts. After that, a lot of times, that's enough. Like with this one, that was enough. I don't have to do anything more. But sometimes if I don't have x-intercepts, I might actually have to like put it in a t-chart, plug in a number, and find something, and then reflect it over. Claire?
Is that what we would do for the first one?
For x squared plus 1, is that what
Yeah.
what you were saying? So x squared plus 1, I'll change this one up here. What's the vertex? Good, so it'd be like up 1, right?
Oh.
So it'd actually be like 0, 1. Would that go up or down? Up, right? That's not good enough, right? Because I need to have something to the left and to the right. So all I need to do is have maybe 2 points on one side. So if I pick like a t-chart, and I said, and this is a great example, I plug in 1 and 2, plug it in, get numbers out, and then know that I just simply reflect it over to that left side and I'm good. Okay. Good stuff. All right, questions? You got roll?
2B over
Yeah.
2bx squared plus 2x plus 1.
I
I think I've got,
When I
I did the one down below, the 28 one.
Like Coach, when it's 2x, is that when you go up 2 over 1? Like that's
Which
when
one
you
again?
do it, like the 2x percent.
That one's different, okay? So let's talk about this, because this is good. Y'all, I've got about 5 minutes. We're going to probably finish off with this one here together, okay? On block day, probably the start of block day, we have about 2 more problems that I wanted to hit on that I'll walk through. And you'll know that, again, it'll be due on Thursday at midnight. So we'll have some time as well. I would, if I were you, try to do a lot of the graphing ones so that you don't have as much homework come Thursday, just as a heads up. But let's do the one I think that Roll was talking about, which was x squared. Let me get a different color here. X squared plus x plus 2x plus 1, okay? All right, let's talk about a couple things. First off, let's do x-intercepts because I think it's the easier part. How do I find my x-intercepts?
I mean, that one just all that.
Is that y
equals 0?
Plug 0 in for y, right? So we get 0 is equal to x squared plus 2x plus 1. What do I do here?
You can factor that, right?
Good, so 0 equals, how do I factor? X plus 1, x plus 1. So when I set both of these equal to 0, what are the x-intercepts? -1, y'all are rocking. So we have -1 comma 0, right? Okay, that's my x-intercept. Now, here's the thing. I put it on the golden nugget and I haven't hit it yet, but I want to show it to you. We have what's called vertex form, which is what we were doing kind of earlier, where if I have an H, it changes it right and left, and if I have a K, I change it up and down, right? And if there's an A, it shrinks and stretches it, right? Here's the one thing. We're going to go into what we call standard form, which is this one, all right? So big idea here. To find the vertex of a standard form, it's a little different on this. To find it, we've got to do what we call negative b over 2a, and then we plug it back in to find whatever my y is. You say, Coach, what are you talking about? What is b here? 2, right? Yeah, 2. So it would be -2 over 2 times, what's a? 1. So what's the x? -1. Good. Good. To find the y of the vertex, I plug -1 back in for x. Good. Let me get a different color so you can see it. So this would be, make sure you use parentheses, -1 squared plus 2 times -1 plus 1. So what's -1 squared? 1 minus 2 plus 1 would be
Or no,
0, yeah? So we would say the vertex is -1 comma 0. Now, here's the thing. It happens that these are the same. That's just by chance. A lot of times it's not. Bless you. A lot of times it's not. So as you're doing it, don't always say that that's the case, because sometimes it will be different. Okay, so let's graph this thing. Where's my x-intercept? Which is also my vertex. Good. Is it going to be a minimum or a maximum? A minimum, because it's going upward. Y'all with me? Okay. So it should be going upward. Although how I did this was inappropriate, right? I need to find something on one side or the other. Now, question. How do I find my y-intercept? They didn't ask for that. Well, what's my y-intercept?
X is equal to 0.
Good. So x is equal to 0 and y-intercept. So that'd be 0 plus 0 plus 1. So what's my y-intercept? 0 comma 1, right? Y'all follow me on this? Okay, I know I'm putting a lot together. So 0 comma 1 would be up here, okay? So if the axis of symmetry is over top of the vertex, I can reflect it over right 1, up 1. I can go left 1, up 1.
Why
And
is
there
it?
you go.
Why is it 0, 1? Why is it not 0, 2? Why is that 2x?
Oh, good question, because remember y-intercept, I plugged 0 in for x. So that would be 0 plus 0 plus 1, which would be an answer of just 1, right? Does that make sense? Okay. Hey, if you want to get ahead, just as a heads up, right here below on 53, it says find 2 quadratic functions, ones that goes up and down with the following x-intercepts. Question, how could I put this, the x-intercepts, into factored form? If I have an x-intercept at -1, what factor would I have? You can just listen right now. You don't have to write it down.
1,
X plus 1, good. And then what would this one be for 3, 0?
minus 3.
X minus 3, and then I just distribute it, and there you are. Okay? Hey, we'll hit some more of this tomorrow or Thursday. Y'all be blessed, and we'll see y'all. Sophia, glad to have you in this class.
Yep.
Me
Well,
too.
You like this smaller class?
Yeah. Grace was really distracting, you know?
Oh, really?
Sit next to.
I got it. See y'all. Have a good day.
What's it called? You get like